In this lesson, you're going to learn how to sketch polynomial graphs using three big ideas: end behavior, zeros, and multiplicities. Let's move through three examples, each one getting slightly more interesting. Example 1, y equals negative times the quantity x plus 2 times the quantity x minus 1 times the quantity x minus 3. Step 1, find the zeros. Set each factor equal to 0. X plus 2 equals 0. X equals negative 2. X minus 1 equals 0. X equals 1. X minus 3 equals 0. X equals 3. All of these appear once, so each 0 has multiplicity 1, meaning the graph passes straight through each intercept. Step 2. End behavior. We have three x factors, so the degree is 3, which is odd. The leading coefficient is negative, so the right side of the graph goes to negative infinity. Odd degree means opposite ends, so the left side must go to positive infinity. Step 3. Find the y-intercept. To find the y-intercept, substitute x equals 0 into the polynomial. When x is 0, the value of the function is negative 6, so the y-intercept is 0 minus 6. Step 4. Sketch. Start by plotting the x-intercepts, negative 2, 1, and 3. From the left, the graph comes down and cuts through x equals negative 2. It continues downward to the y-intercept at negative 6, then turns up and crosses straight through x equals 1. After rising briefly, it turns down again, crosses at x equals 3, and the right end falls. Example 2, y equals x cubed plus 5x squared plus 6x. Step 1, factor completely. Take out the greatest common factor, y equals x times the quantity x squared plus 5x plus 6. Now factor the trinomial. We need two numbers whose product is 6 and whose sum is 5. Those numbers are 2 and 3. So x squared plus 5x plus 6 becomes x plus 2 times x plus 3. Therefore, the fully factored form is x times the quantity x plus 2 times the quantity x plus 3. Step 2. Find the zeros. Set each factor equal to 0. X equals 0. X plus 2 equals 0. X equals negative 2. X plus 3 equals 0. X equals negative 3. All multiplicities are 1, so the graph cuts through each intercept. Step 3. End behavior. The degree is 3 and the leading coefficient is positive. So the right end goes up to positive infinity and the left end goes down to negative infinity. Plot the x-intercepts at negative 3, negative 2, and 0. Start from the left. The graph comes down, crosses at x equals negative 3, rises slightly, then crosses again at x equals negative 2. It continues rising toward the y-axis, crosses at x equals 0, and then rises to the right. That completes example 2. Example 3. We have y equal to the quantity x plus 1 all squared times the quantity x plus 2 all cubed times the quantity x minus 1. Step 1. Zeros and multiplicities. Set x plus 1 equal to 0. This gives x equal to negative 1. The multiplicity is 2. Set x plus 2 equal to 0. This gives x equal to negative 2. The multiplicity is 3. Set x minus 1 equal to 0. This gives x equal to positive 1. The multiplicity is 1. Here's what the multiplicities mean. A multiplicity of 1 means the graph crosses straight through. A multiplicity of 2 means the graph bounces like a parabola. A multiplicity of 3 means the graph passes through with a cubic-style S-curve. Step 2. End behavior. Add the multiplicities. 2 plus 3 plus 1 equals 6. This gives an even degree. The leading coefficient is positive, so both ends of the graph go upward. Step 3. Sketch. Plot the x-intercepts negative 2, negative 1, and positive 1. The graph starts on the left rising and moves through the intercept at negative 2 with a smooth cubic curve because the multiplicity is 3. It then reaches -1, where the multiplicity is 2, so it touches the axis and bounces downward. From there, it heads to the y-intercept, so the graph passes through 0, -8. Then it rises, crosses the axis at +1 with a clean straight-through crossing, and continues upward toward positive infinity. That completes example 3. In this lesson, you learned how to sketch polynomials using zeros, end behavior, and multiplicities. If you want a follow-up lesson on rational zeros, synthetic division, or how to find turning points, let me know, and I'll make that the next video for Algebra and Geometry Explained.